All right, part 2. This is the same slide as yesterday, the fundamental theorem of algebra. We're going to talk about how to go backwards, okay? I'm going to give you some of the answers. X equals this, X equals that. You're going to multiply back together to find the original polynomial. Now think about it, guys. Original polynomial, say you have, this is what I mean when I say that, like f of x equals x to the fourth minus 6x squared plus 3x minus 1. And you're asked to solve. Sometimes you have real solutions, sometimes you have imaginary, sometimes you have square roots. But what do you never have in an original question? You never have i's and you never have radicals. So the way that happens is when you have imaginary answers inside of a problem, or if you have radicals inside of a problem, they always have a conjugate. Because think about it, x squared is always going to give you plus or minus, right? If you have an imaginary, the only way you can get that is from a plus or a minus situation. So what they're saying, and what this is telling you is if you are given a 0, if you're given an x equals, and it is a radical, or it's an imaginary, you have to include its conjugate. And I'm just going to go through some examples, and you'll understand this in a minute. But what is the conjugate? If I gave you the square root of 3, what's the conjugate? What's the opposite of square root of 3? Negative square root of 3. If I gave you 2i, or 3 plus 2i, what's the conjugate of 3 plus 2i? 3 minus 2i, because what's going to happen when I multiply those back together? The i's are going to cancel. What's going to happen here when I multiply these together? The square root cancels. So anytime you have anything that has an I in it as a 0 or a square root, you have to multiply or you have to account for the conjugate. Let me show you what that is. So 2 ways we're going to look at this. It says find the 4th degree polynomial. So a polynomial to the 4th power is what your answer should be. Given the zeros are x equals negative 1, x equals negative 1, and x equals 3i. Well, how many zeros did they tell you had? 4, but they only gave me 3. But do you notice that this one is imaginary? So if they give you an imaginary or a square root, you have to account for the opposite. So not only do I have positive 3i, I also have what? Negative 3i. So how do we work backwards? How are we given all of these zeros, these answers, and we're going to work backwards to find the polynomial? Or we're going to write them in their linear factorization. How do I write this as a linear factor? X plus 1, right? Good. How do I write this as a linear factor? X plus 1. How do I write this? X minus 3i, and this one is x plus 3i. Now, all you're going to do here, guys, this is a huge foiling problem, right? This is a very easy concept, but there's a ton of places to make a mistake. What would I do? Well, I would obviously keep the real with the real and the imaginary with the imaginary, right? I'm going to FOIL these first two right here. So x times x is x squared. X times 1x is x. 1 times x is x. 1 times 1 is 1, right? So when we combine like terms, you have x squared plus what? 2x plus 1. All right? Fair enough? So now I'm going to do these two, the two imaginaries. So when I multiply, x times x is x squared. X times 3i is plus 3xi. Don't worry about how you write it. What's negative 3i times x? Minus 3xi, right? And what's a negative 3i times the positive 3i? Negative 9i what? Squared. As soon as you see that squared, guys, what do? You cross it off and change the sign. So when we combine like terms, you have x squared. What happens to your positive negative 3xi? They cancel, so you just have plus 9. Do you see how your imaginaries disappeared? We put them back together, so now you're not going to have any imaginaries in your final answer because you don't ever have a polynomial that starts off with i's in it. So now what do we do with this? What do we do with this? You FOIL it again. You distribute again. I'm actually going to rewrite it to put the x squared plus 9 in the front. You don't have to. I just like when the smaller amount is in the front. So we FOIL again. And again, everybody in here can do this. It just can get really messy. X squared times x squared is x to the fourth. X squared times 2x is plus 2x to the 3. X squared times 1 is plus x squared. So 9 times x squared is plus 9x squared. Yes? 9 times 2x is plus 18x. And 9 times 1 is 9. And then we combine what? Like terms. So x to the 4th plus what? Plus 2x cubed plus 10x squared plus 18x plus 9 equals 0. So there you guys have gone. You've written the 4th degree polynomial. Means it's to the 4th power. And if you were given that and asked to solve it, these would be the answers. So all you're doing is, in this question, you'll probably get one of these on a test because it takes a long time. You're just going to work backwards. You just have to make sure you account for the conjugate if you have an I or if you have a radical. So I'm going to do another one or two, and then we'll go on to the next thing. We okay? All right, let's do the next one. Here's some examples. So let's do number 2. All right. Write out the answers. They gave me x equals -5. What else did they give me? X equals the square root of 3. Do we ever have a square root in our original problems? No. So what am I going to have to do to make sure those square roots cancel out? You have to account for the negative. So x equals negative the square root of 3. Whenever you have a radical, guys, or an imaginary, you have to account for the conjugate. So now you're just going to put them into parentheses and FOIL. What's your first parenthesis? X what? X plus 5. Good. When you go over the equal sign, it changes signs. Then what? Minus the square root of 3 and x plus the square root of 3. Make sure you're always equal to 0. Now, what would make sense to multiply first? The square roots, right? Because what do you want them to do? Cancel out. Let's just make sure they do. So I'm going to leave x plus 5 just hanging out here in front. So now let's FOIL. X times x is x squared. X times the square root of 3 is just plus x square root of 3. Negative root 3 in x is minus x square root of 3. And then what's negative square root of 3 times positive square root of 3? It's minus 3. It's the square root of 9, which equals 3. So what happens in the middle with your x root 3's? They cancel. So now we have x plus 5 times x squared minus 3. So now at this point you should go, oh, okay, I'm on the right track. Why are we on the right track? Because your radicals did what? They canceled out. Good. So let's FOIL. X times x squared is x cubed. X times negative 3 is minus 3x. 5 times x squared is plus 5x squared. And 5 times negative 3 is negative 15. Do I have anything to combine? No. But is that written in standard form? No. So let's just fix it. X cubed. What? Plus 5x squared minus 3x minus 15 equals 0. Does that make sense? All right, let's do this one, but this gets too long. Cross this off because I want to show you a little bit of a shortcut. Some of us like shortcuts, right? Cross off the 3i because it just makes two more things we have to multiply together. Okay, I have two roots here, but I notice one of them is what? Imaginary. So that means, uh-oh, I actually have a third one. What's my third root? 2 minus I. Good. So let's talk about what we do here. I'm going to write my parentheses. What is this parenthesis going to be? X plus 4. Okay? Right? Your real one, just, that's super easy. This whole root is together. And this is together. So think about this. All right? I'm going to show you this, and then you can just do the process at the same time. If I bring this over, that 2 is positive, correct? So what you're doing, everybody watch, this is x minus 2 minus I. And this is going to be x minus 2 plus I. So what's really going to happen with the signs here? It's going to become x minus, because I distribute x minus 2 what? Plus I. And x minus 2 minus I. You see that? You have to distribute that negative. What I need you guys to take away from that. Do you notice how this sign is the same in both? And this one, the second one is different? Just make sure the first sign's always the same and then the second one is opposite. Because in a sense, when we do this, when you multiply, what do you want to happen? You want the i's to cancel out. Now, I'm going to multiply this the long way. Do not do this. I want you guys to just watch. It would make sense to multiply the stuff with the i's together first, right? So you could say, I'm going to do it over here. X minus 2 plus I and x minus 2 minus I. So x times x is x squared. X times negative 2 minus 2x. X times negative I minus xi. So now we go to negative 2. Negative 2 times x is minus 2x. Negative 2 times negative 2 is plus 4. And negative 2 and a negative I is plus 2i. Agreed? Yes? Okay, check me. So now I have I. So x times I is plus xi. I times negative 2 is minus 2i. And I times negative I is minus I squared. As soon as I see I squared, what do? Guys? Cross it off and change the sign. So there's a plus 1 there, right? Okay, so watch what happens here. I have x squared. I have a minus 2x and a minus 2x. Gives me minus what? Minus 4x? Yes? Okay. So I have a minus xi and a positive xi. Cancels. I have a positive and a negative 2i. They cancel. So then I have 4 plus 1 is what? 5. Okay. That's exactly what we needed to happen, correct? We needed all of the I junk to cancel out. So then you would take this other x plus 4 and FOIL it in. Let me show you a shortcut. Because what's going to happen, again, I know I keep saying the same thing, but I want you guys to see this. What is going to happen if our first sign is the same in each parenthesis and our second sign is different? What's going to happen to the i's? They're going to cancel out, right? Do you guys notice that this is the same? My pen's dying. This is the same in each parenthesis. And this is the same. The only thing that's different is the signs. Yes? So the shortcut is, it's like the difference of perfect squares. You can say that you have x minus 2, 2 times. And you can say that you have I, how many times? 2 times. And what sign do we use with the difference of squares, plus or minus? Minus. So I'm going to put a minus sign right here. So if I were to FOIL this out, x minus 2 times x minus 2. All right, well, x times x is x squared. X times negative 2 is minus 2x. Negative 2 and x is minus 2x. Negative 2 and negative 2 is plus 4, right? You guys agree? Well, what is I squared? Negative 1. So minus a negative is the same as what? Plus 1. So if you combine like terms, do we get the same thing? Yes. You are more than welcome to multiply the whole thing out. It just can be a huge, huge mess. If you guys will follow the difference of perfect squares pattern, it'll work every single time. Like just say you had this. Say you had x plus 3 minus 2i and x plus 3 plus 2i. All right. Do you see how this is the same as this? And this is the same as this? So our shortcut would be what? X plus 3 squared minus what?
2i squared.
Watch this, guys. 2i squared. So this would be x plus 3 times x plus 3, which gives me x squared plus 6x plus 9. Yes? 3x times 3x. 3x plus 3x is, okay. And then what is this? 4i squared. Remember this 2 goes here and here. So if I have minus 4i squared, it's the same thing as saying what? It's the same thing as saying what? Plus 4. So then you had x squared plus 6x plus 13. That shortcut will work every single time. If you don't like it, fine. You can go ahead and multiply out. It's just when you multiply all that stuff out, it gets real hairy. You get your signs mixed up, stuff like that. But every single time you take that first binomial, you square it. You take whatever's with the I, you square it, and put a minus sign in the middle. So we are going to take what we learned yesterday and what we just did right now to solve these kinds of problems. All right, find all the zeros, it says. I'm going to do, how many, hold on. Find all the zeros of this. X to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. All right, how many answers are in this problem? 4. When you have a question that says, here is a polynomial, and here are some of the zeros, fine. They're going to give you the imaginary ones. You're going to discover the real ones every single time. They're going to give you the imaginary. You do this process the same way every time. So let's talk about first what they gave us. They gave me x equals 1 plus 3i. Well, if they gave me 1 plus 3i, what else did they give me? X equals 1 minus 3i. Okay, there's 2 of my 4 answers. The other 2 that we're going to discover are going to be real. How do we do that? All right, first thing we're going to do is multiply these 2 together. So when I bring this root over, it becomes 1 minus, no it doesn't, it becomes x, I don't know why I said that. X minus 1, you can say plus 3i. This becomes x minus 1, what? Minus 3i. If you want to change this one, I don't care, it doesn't matter. Mathematically, this would actually be the minus and this one would be the plus. But it doesn't matter when you do it. What I need you guys to focus on is this first sign should be what? The same, and the second sign should be what? Different. So we're going to multiply these 2 together. I'm going to do the shortcut. What is the shortcut going to look like? X minus 1 quantity squared minus what? 3i squared. Put it in parentheses so you remember that 2 goes to the 3 and to the I. So if we multiply this out, x times 1, I get x squared minus x plus 1. You guys agree? So x squared minus 2x plus 1. What's going to go right here? What is that? The 3 goes, the 2 goes to here and here. So what does that become? 9i squared. If I see I squared, I cross off I squared and I put a what? A plus sign. So this is the same as plus 9. So I got x squared minus 2x plus 10. You guys are like, why? What is the point of doing that? Now we have to take this x squared minus 2x plus 10, and we're going to divide it into your polynomial. X to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. Now, I know you guys don't love long division, but the thing with this is every single time you do this question, the process is exactly the same. They're going to give you one imaginary, you account for the conjugate. You multiply them together, and then we're going to divide. When you divide, you will not have a remainder. If you do, then you did something wrong, because what you're doing is undoing all of this. You're finding the zeros that are inside of here, so there's no remainders. Because if something is a factor, your remainder is 0. So now we just go through, we're going to do our long division that we did on our last quiz, which most of you guys did a really good job with. First term into first term. So x squared times what gives you x to the fourth? X squared. Put it above your x squared right here. So get your subtraction ready before you multiply, and just take your time. What's x squared times x squared? X to the fourth. What's x squared times negative 2x? Minus 2x cubed. And what's x squared times 10? Plus 10x squared. Before you subtract, guys, what do we need to do? Distribute, 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 distribute. So you have 6 minus 10. 6 minus 10. Negative 4, x squared. What's negative 3, x cubed plus 2x cubed? Negative x cubed, and your x to the fourth cancel. And then what do we do with 2x? What do we do with 2x, guys? You bring it down, okay? So now again, first term into first term. X squared times what gives you negative x cubed? Negative x, right up here. Get your subtraction ready before you multiply. So negative x times x squared is negative x cubed. Negative x times negative 2x is plus 2x squared. And negative x times 10 is minus 10x. Before you subtract, what do you have to do? Distribute, 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 distribute. So 2 plus 10 is 12. Negative 4 and negative 2 is negative 6. This is a plus sign, and you bring down your negative 60, right? All right, last one. You guys doing great. You'll have one of these. I know they're long. X squared into negative 6x squared. X squared times what gives you negative 6x squared? Negative 6. So get your subtraction ready. Negative 6 times x squared is negative 6x squared. Negative 6 times negative 2 is positive 12x. Negative 6 times negative 10 is negative 60. Before you subtract, what do? Distribute, 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 distribute. What's a negative 60 and a positive 60? 0. What's a 12 minus 12? 0. What's negative 6, positive 6? 0. So do you have a remainder? No. So your guys are left with x squared minus x minus 6. Set that equal to 0. Every single time this will work the same way. You will be able to factor this. What are the factors of negative 6 that multiply to give you negative 6 and add to give you negative 1? Yep. X minus 3, x plus 2. So what are the two zeros that were hidden in there that we didn't know? X equals 3 and x equals negative 2. It's a very long process. I understand that. But it's like 4 different things that we've done that we put all together. Every single time they're going to give you an imaginary 0. So you're going to multiply by the conjugate, get a polynomial, divide into what they gave you, the big one, and then you'll be able to discover the 1 or 2 zeros that are left over. Pain in the butt, I know. I know. 10, ay. All right, let's do number 2, and then I'll do number 1 on the video. How many answers do I have total? Total, I have 3. How many did they already give me? 2. They already gave me 2. So I only have to find 1 here. So I have x equals negative 2 what? Plus 5i. All right, they already gave me 2. So what do I do first? I'm going to take these 2 that they gave me and I multiply them together, correct? This is a negative 2. So when I bring it over, what's my first sign going to be? Plus. So I have plus 2. You can just keep that minus 5i if you want. And then over here, when I bring this negative 2 over, it becomes what? Plus, and then you can keep the 5i. Mathematically, that first one should be plus 5i. The second one should be a minus, but don't worry about that. All you need to make sure of is that first sign is the same, and it's whatever it should be. If you're originally negative, when you move it over, it's positive. If it's originally positive, when you move it over, it's negative. Then your second sign should just be different, opposites of each other. So do you notice now you have the same thing at the beginning of both, right? So how do I rewrite that for the shortcut? X plus 2, quantity squared. Then I put a minus sign, and then it's 5i squared. In parentheses is your 5i. If you want to go ahead and simplify that one, you can. What does this become? Minus 25i squared, which becomes what? You're going to put plus 25 here at the end. Go ahead and get that out of the way. So now if we FOIL this, x plus 2, x plus 2, x times x is x squared. X times 2 is 2x, and then 2 times x is 2x, so it's plus 4x. And then 2 times 2 is 4. So So your polynomial is x squared plus 4x plus 29. Perfect. All right, that's the first step. So I already know 2 of the answers, so now I'm going to uncover the last one. How do I do that? Well, I take x squared plus 4x plus 29, and I divide it into x cubed plus 11x squared plus 57x plus 203. How do we do long division? First term into first term. So x squared times what gives me x cubed? X. So look, guys, I'm going to put the x right here above 57x. Get your subtraction ready before you multiply. X times x squared is x cubed. X times 4x is plus 4x squared. X times 29 is plus 29x. Before you subtract, what do we need to do? Distribute. So we're going to distribute, 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 distribute. What's 57 minus 29? Look, guys, 57 minus 29. Don't wait for someone else to do it. 17 minus 9 is 6. 4 minus 2, so 26. What is it? 28. I just see if nobody's even looking at it. What happens with 11 minus 4? Oh, okay, we got that one. And then what do I do with my x cubes? They cancel. What happens with 203? Oh, geez, 203. So now, guys, first term into first term. X squared times what gives me 7x squared? Plus 7. Get your subtraction ready before you multiply. 7 times x squared is 7x squared. What's 7 times 4? 28, okay. What do you think 7 times 29 is? It is 203. And what do I have to do before I subtract? I got to distribute, 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 distribute. So what do you see happens with 203 and positive and negative 203? They cancel. Positive, negative 28 cancels. 7x squareds cancel. So you're left with x plus 7. Every single time, guys, you'll have no remainder. What do I do with x plus 7? You get x plus 7 equals 0. So what's the other x value? Negative 7. These problems are long, but there's no trick to anything. You'll never see it any other way. You'll always see it, here is the 0. Account for the conjugate, multiply them together, long division, no remainder, factor. Every single time. Every single time. All right, I'm going to do the next one. You can pay attention if you want. No. All right, so this one we have x equals 3 plus 2i. So we also have x equals 3 minus 2i. So we're going to first multiply. So when we bring positive 3 over, it becomes minus. So I have x minus 3 and plus or minus 2i. X minus 3 here. So we're going to write x minus 3 quantity squared minus 2i here and here. So we have 2i quantity squared. So when we FOIL this out, we have x squared minus 3x and 3x is 6x. Negative 3 times negative 3 is 9. And then here I have minus. This is going to be 4i squared because this 2 goes here and here. So this crosses off, cancel. So I have plus 4. So I have x squared minus 6x plus 13. So I'm going to use that to divide into my polynomial. So x squared plus or minus 6x plus 13. We're going to divide that into x cubed minus 11x squared plus 43x minus 65. So we've already found 2 of our zeros. We're going to find the real one that's undercover here. So x squared, first term into first term, x squared into x cubed goes x times. So let me put it right here. Go ahead and get our subtraction set up. So x times x squared is x cubed. x times negative 6x is negative 6x squared, and x times 13 is plus 13x. Before we go ahead and subtract, we're going to distribute, so change. So 43x minus 13x is going to give me 30x. Negative 11x squared and a positive 6x is going to give me negative 5x squared. This is a plus there, and then I bring down my negative 65. So, for a different color, first term into first term, x squared times what gives me negative 5x squared. It's going to be a negative 5. So let's just make sure we didn't make any mistakes with our signs or anything before we just say x equals 5. So we'll say negative 5 times x is negative 5x squared. Negative 5 and negative 6 is plus 30x. And negative 5 and 13 is negative 65. So then when we distribute, this comes plus, minus, and plus. So negative 65 and 65 cancels. 30 and negative 30x cancel. Negative 5x squared and positive 5x squared cancel. So we're left with x minus 5. We set that equal to 0. And we find that our other solution is x equals positive 5.